Bismillahirrahmanirrahim. Assalamu alaikum, dear student. I do hope you will be in best of your health. In last lecture, we have studied variation of parameter method. In the previous lectures, uh, many students were absent. In today's lecture, I will I will solve a few more questions with the help of variation of parameters, so that the student who have not attended the previous class may get benefit of this. First of all, I will give you a review of variation of parameter method. We have studied this method for second order non-homogeneous differential equation. As I told you in the previous lecture, this method is for non-homogeneous differential equation. Earlier we have studied undetermined coefficient method. Today we will learn another method, variation of parameter method. In this method, the solution of homogeneous part is obtained in a similar manner as we have got solution previously. The difference is the solution of non-homogeneous part. In non-homogeneous part, the solution of non-homogeneous part is denoted by yp. In this method, the constant C1 and C2 are replaced by U1 and U2 as in the complementary solution. And the value of U1 and U1 is determined as U1 prime is equal to W1 divided by W. And W I have defined in the start of this chapter. W is the Wronskian. If we have second order ordinary differential equation, then Wronskian will be y1, y2, y1 prime, and y2 prime. And w1 will be we replace the first column y0 and non-homogeneous part fx, and the second row is same y2 prime. And w2 we replace first row is same y1 prime, and second row is second column is replaced with the entry 0 and fx. In this manner, we will find the parameter u1 and u2. We have defined u1 prime and u2 prime. While integrating u1 and u2, we will get u1 and u2. Now I will demonstrate this method with the question. In the last lecture, we have solved 2 to 3 questions and one example with the help of variation of parameter method. Now I will solve the different question. That is question number 11. Question number 11 is y double prime plus 3y prime plus 2y is equal to 1 divided by 1 plus e power x. The auxiliary equation corresponding to the homogeneous part is m square minus 3m plus 2 is equal to 0. If we solve this equation with the help of pair m square, 2m plus m plus 2 is equal to 0. Taking m common from first two entries, it will be m into m plus 1, and taking plus 1 constant from entries third and the fourth one, plus 1 uh, into m plus 2. M plus 2 into m plus 1 is equal to 0, and we will get values of m. M is equal to minus 1 and minus 2. The values of m is distinct, so the solution will be written with the help of case 1. Distinct root yc is equal to c1 e power minus x plus c2 e power minus 2x. That is the complementary solution, which is the solution of homogeneous part. Now, in order to determine the solution of non-homogeneous part, it is denoted by yp. We replace c1 and c2 with the parameter u1 and u2. Here, if y1 is equal to cos of x and y2 is equal to sin of x. First, we will determine the Wronskian, and Wronskian is a function of y1 and y2. y1, y1 prime, y2, and y2 prime. Value of y1 is e power minus 2x, and its derivative will be minus e power minus x. Y2 is equal to e power minus 2x, and its derivative will be minus 2 e power minus 2x. And if we determine this determinant, we will get e minus e power minus 3x, which is never equal to 0. It means that we can determine the solution. Now we will determine the W1, and we replace the first column with entry 0 and fx, and here fx is equal to, I have not defined earlier. Yeah, here fx is equal to fx is the non-homogeneous part, is equal to 1 divided by 1 plus e power x. I will zoom it so that it is visible. Fx is equal to 1 divided by 1 plus e power x. And in order to determine W1, the first column will be replaced with 0 fx, 0, and fx is 1 divided by 1 plus e power x, and y2 e power minus 2x, and its derivative will be minus 2 e power minus 2x. If we evaluate this then determinant, if we evaluate this determinant, we will get e minus e power minus 2x divided by 1 plus e power x. Now we will find W2, and first column will be same as W, e power minus x, its derivative minus e power minus x, and second column will be replaced with 0 fx, 0, and fx is equal to 1 divided by 1 plus e power x, and we will get e power minus x divided by 1 plus x, e power x, and u1 prime will be equal to W1 and W. W1 value is minus e power minus 2x divided by 1 plus e power x, and W's values is minus e power 3x. If we simplify this, we will get e power x divided by 1 plus e power x. In order to find the value of u1, we will integrate this u1 prime, and we will get natural log of 1 plus e power x. This is u1. Now, in order to find u2, u2 prime is equal to W2 divided by W, and W2's value is e power minus x divided by 1 plus e power x, and W's value is minus e power minus a minus 3x. If we simplify this, we get minus e power 2x, and we separate it into two terms, minus e power x divided by 1 plus x. We have done this purposefully so that we can simplify this integral minus 1. I have add 1 and separated 1 plus e power x minus 1 into e power x divided by 1 plus e power x. We can write this factor 1 plus e power x in the first two entries. It will be cancelled, and we will get 1, and multiplying by e power x, we will get minus e power x, and we will write the denominator under minus 1. So then we will get e power x divided by 1 plus e power x. The plus sign is came because minus and minus, after multiplying, it will be converted into plus sign dx. If we integrate this, then we will get u2 is equal to minus e power plus x plus natural log of 1 plus e power x, and yp will be equal to, after using yp is this one, yp is this one, and after using the values of u1 and u2, we get yp is equal to natural log and 1 of 1 plus e power x into e power minus x, plus minus e power x plus natural log of 1 plus e power x into e power minus 2x. And the total solution will be is equal to y is equal to yc plus yp. That is the yc is the solution of homogeneous part and yp is the solution of non-homogeneous part. And y is equal to c1 e power minus x plus c2 e power minus 2x plus natural log of 1 plus e power x into e power minus x plus minus e power x plus natural log of 1 plus e power x into e power minus 2x. This is how we get the solution of this question. Now we will solve another question. This is the question number 14. Y double prime minus 2y prime plus 5 is equal to e power t arc tan of t. It means that tan inverse of t. As the equation corresponding to homogeneous part is m square minus 2m plus 1. If we solve this equation, we will get the values of m is equal to 1 and 1. This is the repeated real root, and we get this. We will write the solution using the case 2. Yc is equal to c1 e power t plus c2 t e power t because the entry is repeated. I'll zoom it so that it may be visible, more visible. And a particular solution will be we will replace the constant c1 and c2 with parameter u1 and u2. Here y1 is equal to e power t, y2 is equal to t e power t, and f of x is equal to f of here function is a t, f of t is equal to e power t and arc tan of t. And we will determine w is equal to y1 prime, y2 prime. If we simplify it and put the value y1 and y2 and their derivative, we get the value of Raskin is equal to e power 2t. To find w1, we replace the first column with entry 0 and fx, and second column will be same as w's. And if you simplify this, then we will get w1 is equal to minus t e power 2t or tan of t. In order to find w2, first column will be same as w, y1 prime, and second column will be replaced with entry 0 and fx. If we simplify this, we get e power 2t or tan of t. In order to find the value of u1 and u2, u1 prime is equal to w1 divided by w, and we'll get u1 prime is equal to minus t or tan of t. Now to find u1, we integrate this. This is tan of t. If we integrate this using with the help of integration by parts, integral of t will be t squared divided by 2, and arc tan of t will be remain as it is, plus integral t squared divided by 2, and derivative of arc tan of t is equal to 1 divided by 1 plus t square. If in order to find the integral, we will add 1 and subtract 1 and write denominator in the first two entries, and we will get 1 and minus 1 divided by 1 plus t square, and we will get the result minus t square divided by 2 arc tan of t plus 1 by 2 t minus arc tan of t. If we separate the entry of tan inverse, we will get 1 by 2 t plus 1 minus t square divided by 2 arc tan of t. In similar manner, we will find u2. U2 prime is equal to w2 divided by w, and it will be arc tan of t. We cannot find the integral of tan inverse directly, so we will write it as 1 dot arctan of t. Integral of 1 will be t arctan of t after using integration of parts minus integral t derivative of arctan of t will be 1 divided by 1 plus t square. If we multiply by 2 and divide by 1 by 2, so then we write this integral as minus 1 by 2 natural log of 1 plus t square, and we can write the yp particular solution where u1 is equal to 1 divided by 2 t and u2 is equal to this one. This is yp, and we can write the total solution yc is equal to this one. System is not responding. Okay, we have found the complementary solution and the particular solution. You can combine this. So dear student, today we have solved another 2 question so that you can better understand this method. You solve more question from the exercise. If you have any problem, inshallah we will discuss in our regular online classes. Till then, Allah Hafiz.